A doctor orders 5 milliliters of phenobarbital elixir. If the phenobarbital elixir is available as 30 milligrams per 7.5 milliliters, how many milligrams is given to the patient? I've already gone ahead and highlighted the important pieces. We have the amount of phenobarbital that we need, and we have the concentration, which is basically like a density, 30 milligrams per 7.5 milliliters. We can go ahead and use that as a conversion to move from milliliters, the amount that's actually given, the 5 milliliters, to the milligrams. Now, as I set this up in dimensional analysis, I'm basically setting it up to do multiple conversions. As I realized and stopped myself, I don't need to have times an additional conversion. I've already met the milligrams that they've asked me about. I go ahead and I multiply across the top and divide by the product of the bottom to find out that I need 20 milligrams to give to the patient. And that's 5 milliliters will do that. Next, a doctor orders 2.0 milligrams of morphine. The vial of morphine on hand is 10 milligrams per milliliter. How many milliliters of morphine should you administer to the patient? Remember, we only want to give 2 milligrams total. Each milliliter is going to have 10. Again, this is a dosage or a concentration that we can use much like density as a conversion, where, in order to get milligrams to cancel, we've got 10 milligrams on bottom, so we're effectively dividing by 10, and it was per milliliter, 1 milliliter, that's going to be on top. We multiply across the top, divide by the product of the bottom, see that all of our units that need to cancel will, and we get our answer. With the next one, we're going to deal with sunscreen. The sunscreen is going to contain 2.5% of the active ingredient, or at least one of the active ingredients, by mass. If a tube contains 4 ounces of sunscreen mixture, how many kilograms of the active ingredient at hand are needed to manufacture 325 tubes of sunscreen? We go ahead and we start with our total number of tubes. We go ahead and figure out how much mass is there by using the conversion of 4 ounces per tube. We look up some conversions that allow us to move from ounces to pounds and then pounds to kilograms so that we can get it into the kilogram unit at the end. And then because it was 2.5% by mass, that means 2.5% are going to be our active ingredient out of 100%. The percentages will serve as a unit and they'll go ahead and cancel. We go ahead and solve everything. Tubes cancel, ounces cancel, pounds cancel, kilograms remain. Percentages also cancel. Remember, this was sunscreen in the tubes or sunscreen mixture, so that's also going to cancel. We multiply across the top, we divide by the product of the bottom, and we'll have our answer. We get 0.921 kilograms. We're going to stop after 3 significant digits because we had 3 significant digits of our active ingredient in percentage, 325 tubes. The only thing that might cause us to do 2 significant digits is the 4.0 ounces. So if you wanted to, you could make it 0.92 kilograms in case you got feedback that told you you were wrong. The next one, we have volume displacement. We have 50 grams of silver and 50 grams of gold going into 75.5 milliliters of water. These objects of gold and silver are going to cause the water level to rise. Now, we don't know the exact size of these objects, and so we're going to use density of each that we looked up off of a reference, perhaps a periodic table, to figure out how many grams there are per milliliter. Then we can apply that to the 50 grams of each and figure out what the volume of each of these objects was. When we go ahead and add the volume of these objects together, we can figure out how much volume got displaced in the water and therefore how much the water went up. So when we do this, the gold is about twice the density of silver, and so it's going to be about twice the volume for the silver than the gold. And so you can see that there where we've got roughly 5 milliliters of one and about 2.5 of the other. When those two come together, we get around 7.36 milliliters. And we're going to go ahead and add that to the 75.5 milliliters to see what the new water level would be. Remember, it asked what is the new water level in milliliters in the cylinder. When going ahead and adding these together, we're supposed to stop at the tenths place, the least significant decimal place, and so we get 82.9. As far as our multiplication and division go, they also would have provided us with 3 significant digits. Also, this one with liposuction. A doctor removes fat deposits from a person's body. Fat is less dense than water, so like oil, it would float on water. And we're going to go ahead and remove 3 liters of fat from this body. We'd like to convert that into pounds so the person knows how much weight they should expect to lose. So we start with our 3 liters, the amount that was missing, going to go away. And we're going to go ahead and convert it to milliliters, because the density of fat was provided in grams per milliliter. If we convert it to milliliters, we can go ahead and figure out how many grams of fat. They wanted pounds, though. So we go ahead and convert grams to kilograms. And then we use a conversion that we looked up that allows us to know that there are 2.205 pounds for every kilogram. Go ahead and do this, multiply across the top, divide by the product at the bottom. You'll find out that this person should expect to lose 6 pounds of pure fat. With the final one that I'm going to show, we've got mouthwash. It has ethanol or alcohol in it. This is why some people are a little bit nervous to wash their mouth out before they go driving. They assume the alcohol is still going to be there. Remember, you are supposed to be spitting this out, so it shouldn't really be that big of a deal. If each bottle contains 0.358 pints of mouthwash with a density of 0.876 grams per milliliter, how many kilograms of ethanol are in 180 bottles of mouthwash? So we're going to start with our total number of bottles. Because we know how many pints are in each bottle, we'll go ahead and figure out how many pints there were if we were to solve right now. Since we wanted to deal with it in kilograms and the density was in grams per milliliter, we need to move from pints to milliliters. And so I went ahead and I looked that up, and you can do the same. There are 473.176 milliliters, roughly, for every 1 pint. After we're into milliliters, we can go ahead and use our density to move from milliliters to grams. And once we're into grams, we can go ahead and figure out how many kilograms there are by converting grams to kilograms. Now this would give us our overall mass of the bottles of mouthwash, but we want to know how much ethanol is there. And so we'll have to apply the 21.6% to that. And so that's going to be our final step in the conversion. We go ahead and we take a look at all of our units. Bottles cancels, pints cancels, milliliters cancels, grams cancels, kilograms stays, percentage goes away, treated as a unit. We multiply across the top, we divide by the product at the bottom, and we end up with the kilograms of ethanol that are total here. We solve and we get 5.77 kilograms of ethanol. Again, remember, we made 180 bottles.